Mute it, and then going over here. And we're gonna edit. Then we're gonna look at the thumbnail. Oh. Okay, I got the live stream set up. I think I managed to get the thumbnail saved. Check. Oh, this is bad. There we go. It's a little bit more good for the thing. Okay. I got my live chat pulled up on YouTube. Oh, I need a invite link for the folks on YouTube. And give it that. Okay, now you guys have the Discord invite link. Here, you guys can check out the prompts for the problem while we're waiting to start. Oh, and I can put the resources in range. Yeah. Cool. Okay, I have the YouTube live chat. Oh, I don't have the live chat for Zoom pulled up. There we go. Got it. I need to tell the Discord people to join. There we go. Got the Discord people pinged. Okay. I think that's everything important. Yeah, I think that's everything important for setting this up. Cool. Yeah, so today's going to be a really tough problem. We're of course going to give it a couple more minutes for people to get joined. Yeah, I mean, I first found out about this problem a few months ago. And it's been intimidating me for a while, but we are actually coming up on our 50th system design problem covered next week. This week is problem number 49. And I want to make problem number 50 something exciting. I'm feeling Ticketmaster, which is really related, but a little bit different. So I was like, why not cover flash sale and then Ticketmaster next week? They're both really scary problems, but I think for problem 50, it'll be worth it. Right, I'm going to mute myself, but we're going to kick it off at 10:45 PST. All right, it is 10:45 p.m. We can go ahead and kick things off. I can go ahead and kill these. So now the people watching this asynchronously know that we're going to kick it off. For tonight's problem, we got a very exciting question, flash sale. It's one that's intimidated me for months. I've known about this prompt for several months, and it's just been one of the handful of scariest problems that I've ever came across, because it's really common for senior and even I think principal level questions. It's one of the most challenging problems out there. I want to check. Are you guys able to hear me all right? Can I get a thumbs up in the chat? Should we be in for this live stream? Oh, I don't. What? The Discord link is expired. I'm sorry. No, I see 4 people that joined it. I do see 4 people that joined it. You guys should be fine. And then I don't actually use the Discord during the live stream. I just answer questions asynchronously. It's for offline discussion. I'm a lot more responsive there. You guys might have noticed that I don't respond to comments on YouTube. I'm not responsive on good. You guys can hear me. Great. I really wanted to check that I'm heard well, since this is a hard problem and it's going to be intimidating I don't want to have to do this problem twice. So the Discord link is for offline discussion, since I'm not responsive on YouTube. It's an intimidating problem, flash sale. Let's go ahead and keep going through the resources. It wasn't in any of my books. There's nothing very helpful. I mean, there's stuff that's kind of similar. There's stuff that has somewhat similar problems. Nothing at like a high scale that also is that just really hits the nail on the head for this prompt. I've got 3 different prompts for very similar iterations of this. Ticketmaster is a different problem. Ticketmaster, the way that Steve from A Life Engineered likes to ask it, is a completely different problem than this one. This one, what's distinctive about it is that there's a counter. It's going to involve it specifically is a counter inventory problem, rather than in Ticketmaster you kind of flatten out the counter in the way that Steve likes to ask it, and so then that becomes a very distinctive problem. But these 3 are prompts that I've come across for requesting this. I've been aware of this since like December or maybe even November. And I've just been totally terrified of this problem. So I've just been putting it off for so long and trying to learn more about system design in general so I can give a good answer on it. So like I said, my books don't have anything that really truly hits the nail on the head. There's a case of the problem being covered in interviewing.io. The candidate was knowledgeable. They were knowledgeable. They didn't, they made a lot of the mistakes that I would have made months ago. I did kind of skim through it. I didn't go through the feedback as much as I would have liked. They definitely did something really naive, and I'll cover the naive solutions, of course. I'm definitely going to cover the naive solutions, of course. But they did something really naive, which is common of the interviewing.io and exponent videos, is that it's mocks and it's not necessarily somebody that actually knows what they're doing. It was definitely a knowledgeable candidate, but it's such a hard problem. This guy called Mr. Cap, I've kind of been paying a little, he's like one of the other up and coming YouTube channels, kind of like my own. He took a shot at it. I haven't actually had the time to read through all of it, go through all of his stuff. Interesting enough, I found out interviewing.io actually has transcripts of each of their YouTube videos. And so that is actually, that would be very helpful. It's so hard to watch an hour-long video. I can sympathize with that a lot. And then, so they actually do have transcripts, which is super cool. So Mr. Cap's an up and coming channel, kind of like my own. His is a lot smaller. He's not as active. He has a much smaller volume of problems. He took a shot at it. I didn't manage to go through all of it, but he took a shot. There's so few people that have actually taken a shot at flash sale. There's a nice article on fairness over here. We're definitely going to see that come up. I am going to discuss fairness as a trade-off between the different approaches. And then there's a video on how Shopify handles flash sales. That's probably going to be the closest to an absolute answer that you can find, I'd imagine. But so I haven't had a chance to actually look through that myself. And then a lot of the times the stuff in info Q can be a little bit too abstract. I've seen in a lot of cases the architecture diagrams don't truly go deep enough in some cases, and so there's they know that the engineers have hands-on experience, know exactly what the service does, but they don't actually go deep enough on really explaining things sometimes. But I'd imagine anything that's close to an absolute answer key on this would probably be from them. I'm going to give it my best shot. Yeah, so here's the 3 problems. Give me a question, shoot something in the comments if you have any questions on clarifying this. But yeah, this has been asked in 3 different places. Amazon asked something really similar, which was a little surprising. And then I think even Google's asked this. It has definitely been asked at TikTok. This is a very popular question at TikTok, which is no surprise because it's an absolute ball buster. It's like just such a, I would, if I had encountered this problem a year ago when I was interviewing, I would have been terrified. I'd probably give it a crappy answer. I would not have known what to do. I'd probably have given something roughly like what I saw on the interviewing.io answer. It wasn't, I'm roasting them, but honestly, they did seem pretty knowledgeable. It's just, I know a couple of issues that they made. Anyways, most of it revolves around, there's like 100,000 people or 6 million, and you're going to have it all happen. So this one's within 10 minutes. This person says 100 million users. This one is 6 million. Let's put down those numbers. 100 million on that one. We got 6 million on the middle one. First one is 100K concurrent. And then for the time periods, we had I think the first one just said concurrent, which is not super helpful. I think that means roughly like it just wants 100K TPS. For the second one, it is 10 minutes, and that comes out to about 10K TPS. So that one was I'm gonna say 100K TPS, and then for the third one, we've got, so the amount of actual inventory itself also varies a little bit. 6 million people. Well, so this one doesn't even tell you how many people, but you'd assume that it is around that same rate. But that's another thing that varies between them. But it all is close enough that it still is the same prompt. You still have like the same looking solution. The only difference is just like how many machines that you're going to come out to. And then another thing that varies is, so I was kind of recording the requirements. So the inventory changes up a little bit, but it's overall a very limited inventory. It sells, it's going to sell it within seconds, very high volume of requests, 10K TPS to 100K TPS, 100 million, and it is within, it's right at midnight. You only have 100 for right at midnight. That one is, yeah, like the hairiest problem. That one is probably total order broadcast is what you would end up doing. I don't see like how quickly it actually happens. I don't think it actually is like right at the same second, but it doesn't say how quickly, like over what duration the 100 million users are going to try and hit it. Yeah, 100K TPS, I like that number a lot. And then depending on the variation, you can argue about what you truly mean by fairness. And there's something in the resources is there's a good discussion of fairness in this one, I guess. And I'll discuss that myself too, is how fair we're going to make it. Is it going to be a straight lottery? Some of the approaches that are common would theoretically or would just straight up come out to a straight up lottery. And so that's why they're somewhat naive. And then depending on the variation is whether or not payments will fail. Another one is, oh, I didn't even record this one, is how accurate the counter is. Whether the counter needs to be exact. And that is really hard to do for, you can't do that with Redis actually, with a CRDT. But this one requires an exact amount, and it says payments can fail. So depending on the variation, payments might fail. The counter needs to be exact. That really puts a strain on things. I think in the interviewing.io one, they also had a constraint of 100 millisecond latency response time. So that I'm going to throw that in there too. This is like, these are like really, those like really shape the response that you can get. Yeah. So limited inventory, high volume of requests, retaining order request is important to varying extents. That's the concept of fairness. There's actually a discussion in specifying systems by Leslie Lamport. He actually uses that term fairness as well. It's a really, really hard book to digest, and it's actually on TLA plus. So I wouldn't recommend getting specifying systems unless I'll write that up in the resources anyways. Import for discussion of fairness. Yeah, all right, we're going to record it there anyways, just in case somebody does actually want to dig into it, but I would not recommend it as your first system design book by far. Yeah, you don't want to do that. Yeah, well, so, depending on the variation of these things, I'm going to try and I'm going to try and satisfy all the constraints that we have here. Are there any questions about this problem? Does it make sense to everyone? All right. I'm going to try and jump into our first naive approach for the night. Feel free to drop any questions in the comments if you can think of any after we get going. I'd be happy to jump back into any questions that come up. But yeah, let's go ahead and start jumping into the diagram. Yeah, so first thing, map out your entry points and exit points. So we're going to have user requesting, user placing an order. Yeah, so the famous burger problem, free burger app is one example, but in all the cases, we're just going to generalize it to they're placing an order. They can't see a counter. There was nothing in the requirements about saying how much inventory is left. So we're just going to say there's a button they press and it sends an API request. And so, there's various things that you can do in the back end, such as using possibly a message broker, but it would always have to hit the backend service first. And so we're going to call this the ordering service. We're first going to have some kind of ordering service that we're going to place. And so in the end, it's going to boil down to, you got this request that comes in, and then the service is going to do some stuff. It might place it onto a queue or something. And then you're going to have a response that comes back. And then what happens between the request and the response, that still is up in the air, but here's the entry point. And then you might have, depending on the prompt, you might have a payment service. You can get away with not even touching the payment service at all if it's just a straight up free burger. You don't even need to handle payments at all. And so that simplifies the problem. And that would be great. And so I'm going to cover that a little bit. Yeah. All right. I see a couple questions in the chat, but we got the ball rolling. This isn't actually a full answer yet. I'll answer a couple of questions first. Any constraints on what DB that we can use? And for example, can we use Spanner? And so like if you're using Spanner, like that comes with total order broadcast completely packaged up. And so I thought that would be a little bit of a cop-out answer. So I think it is fair game. I think it is fair game in some cases. And I think there was another problem where I was like, you probably can just use Spanner, which comes with total order broadcast packaged up. I haven't seen any constraints placed about like, hey, Spanner's not fair game. And like, so that's a great question, because Spanner just simplifies this question so much. And so I might actually cover that a little bit. Spanner's also really useful for the auto increment feature. Like, so I'm pretty sure you can do an auto increment primary key, for example, or something like that. I heard when you're using Spanner, you actually don't even have to specify the primary key, which would be like, that's just so overpowered, as if you don't even have to specify a primary key to Spanner. That's what one of my friends told me, at least. Yeah, I mean, it's kind of an answer. It makes the problem so much less exciting. So it's kind of a cop-out answer. But I think, like, if you actually got this question at Google, it probably gets a thumbs out. Most people are just so, if you're interviewing at Google, you got to get a really sophisticated response, right? And I feel like that probably is something that rules out a lot of people and filters them out. So you know what? I think I'll try and cover that as an approach. It will be a fun approach, I think, using Spanner. We'll try and do that. It would not be satisfying to just throw Spanner at this and call it a day. So I want to cover some other stuff too, but I have never seen anybody that gave a prompt that ruled out using Spanner and called it, which is so funny because it just simplifies it so much. All right, anyways, let's go ahead and keep going. So a lot of people just think like, hey, why don't you just throw a broker in there? This is our first naive approach, is that we're going to have Kafka. That has issues, is that it doesn't maintain ordering across the shards. It would be so cool if we could just use Kafka, because then that just eliminates the scaling issue like completely. And then you would just have some processors on the end that are doing some stuff, and you don't have to worry. Like, the only stuff that you'd actually have to worry about scaling up, if you're going to do that, is just this chunk right here. Just this chunk right here is like all you would need to worry about for scale. And then, like, if your consumers are underscaled, that just means the orders are going to sit on the Kafka stream. And you only have to make sure Kafka is scaled up enough. So it's a really convenient solution in terms of scale, completely eliminates the scaling issue, but it turns it into a lottery because Kafka does not maintain ordering across shards. There's some tricks that you can do to make it a little bit better, and I'll get into that approach too here in a second. But I'll first talk about this briefly. I want to like really elaborate on this problem and capture the information I've just covered. So let's go ahead and say approach one. It's naive approach one, Kafka. And so eliminates scale issue completely for everything outside the dashed lines. So I like this approach because of that, is that it does actually hit the scale issue. And that is the crux of this problem, is like, hey, there's the scale thing, but it turns fairness into a lottery. Straight lottery, because it doesn't maintain it across the partitions. And then also the consumers can consume at different rates. And so, I mean, it still maintains ordering within a single shard, but like across the shards, you're not handling that properly. Not maintained across shards. And so then, of course, you could also get your timestamp off of that. And then, so right now we're going to say that our message looks like this. We're going to have user ID of DEF ABC 123 DEF ABC. Sure, yeah, we can do that. And then we're going to improve this by getting our timestamp on the backend server itself. That's going to introduce the issue of clock drift. So it's a little bit better. It's a little bit better. There's a couple of other issues, but approach two is Kafka and backend timestamps. I'm going to do, oops. Nope. Plus backend timestamps. And I like this one. This actually, if you didn't have this 100 millisecond latency expectation, it would solve it. It would solve it without the 100 millisecond latency expectation, because now you've completely offloaded it to the task runners, and then you just wait like an hour or something. This is pissing me off. Okay, so you're going to get the timestamp here, and then you have here on, you have the timestamp there, and so it's recorded here, and then when it's out of order over here, you would still have the proper timestamp on the receiving end over here. You would be able to put it back in order later on, if not for clock drift. So it's not as bad of straight lottery because you're getting the timestamp over here. So we're going to say, let me record that information. Timestamp recorded here, still susceptible to clock drift. I think that's what it's called. There's a discussion about that in DDIA. I think there was a couple of comments in the chat. I'll get to that in a minute. So still eliminates that. It turns fairness in, I didn't put fairness in quotes. That's like a really, really important term here is fairness. If you don't care about fairness in this problem, it's not an exciting problem. So fairness is handled better. Fairness is handled better, but you have clock drift. And so I don't think it'd be reasonable for a person at like mid-level to like know about the intricacies of clock drift and like how that's going to shape things as much. And then you don't have the 100 millisecond latency. You've just thrown that out the window. Thrown out. That also applies to the previous one. I mean, if the 100 latency is just on this little piece right here, and it's like, yep, we got your order. I mean, you're fine. But I think when they're talking about the 100 millisecond latency, they're talking about the processing time for whether or not you actually got the free burger. So I should maybe record that is for the order receipts or for successfully landing a free burger. So like for the order receipt or like your lottery enter, like, yeah, I mean, you get the 100 millisecond latency just fine here, but like I'm pretty sure they're referring to the processing time of like whether or not you actually did get the free burger or not. Okay. So we got the timestamp there, and then we also want to record that over here. Let's do 167.0.0.0, 5000. That is a Unix epoch timestamp. So this is a little bit better, and I like this approach a lot. This is pretty close to solving it. And then we're going to have to get rid of this broker, though, if we want to handle that 100 millisecond latency exactly. We would need to get rid of that if we did. But otherwise, you would just have these task runners over here, and you would have your data store. You'd have some kind of let's go ahead and draw out the rest of it, because this is actually roughly the approach that they had in interviewing.io, is that they just had they used a message broker, and the issue is that it's like if you actually want to handle the whole thing within an appropriate amount of time, you can do that. And you can even handle the so for the payment aspect with Amazon, it would even handle that as well, is that you would even also be able to handle the third-party payment service. It's the payment processor like Stripe or something. I know there's questions in the chat. I'm sorry, I'll get to it in a second. But so for that one, it's really convenient. I think they even talked about using an orchestrator, which is like, yes, like an orchestrator is just so reliable for handling this. If you're allowed to use a broker, if not for that 100 millisecond thing, and just being able to handle it at your leisure, like this totally would have had like it would have totally been like a much more winning approach, and I would have like totally given it a thumbs up. But I want to handle I want to make sure that we handle that scenario of successfully landing a free burger within 100 milliseconds, and we're going to cover that. Now let me get through the chat. Yeah, let me see what we got here in the chat. Okay, can you make the font larger for seconds? Kate? Oh, yeah, I'm sorry. Large. Let's make large. And I'm going to post this in the chat afterwards in a pinned comment. I'm going to put this in a pinned comment in the comments below after the video, of course. Sometimes it takes me a little while to get around to it, but I do always put it into the chat, at least recently. It's like the last couple months I've been doing that. Make this one large. There we go. I made the font larger. What is job of the task runner in approach 1 and 2? So you with Kafka, it's pull based, not push based. You have to pull the messages off of Kafka. And so what Kafka supports is 10 pulls per second at about 1,000 messages per back and forth, but you have to pull the messages off of Kafka. Redis pub sub is push based, and so it actually, I think the internals of it actually are the write ahead log, just like a database, and then it like sends it out to the, it like pushes it out to whatever you specify to the consumers. So, but Kafka is pull based. You have to pull messages off of it. But in a distributed world, we cannot rely on system time for ordering. Yes, clock drift. What you're referring to is clock drift, and I am going to talk about that more. Is that it's more fair, it's better, but you still have clock drift, like I said. Yes, so that's why you can fix that with total order broadcast, which Spanner has for you. You just get that totally for free off of Spanner. What is clock drift? Oh, yeah. So clock drift is about how network, what's the protocol called? NTP, Network Time Protocol. So Unix machines get their time off of NTP protocol, which is so it has millisecond accuracy, has millisecond shoot, there's that thing about what's the difference between accuracy and precision, and so it's millisecond precision, but then but accuracy is actually off by like it's like 5 milliseconds minimum. I think it can even be as much as 500 milliseconds. There was actually something in if you go to it's Jepsen.io's content on, it's either Spanner or it might have been CockroachDB, discusses how bad clock drift can get. Here, I'll put that in the resources at the top too. I'll put that up there. Okay, but so the clocks were off by each other by a certain amount, and so they would not actually be putting things, it's not actually the correct ordering across all machines when you're relying on the clocks. It's a little bit better than you would have gotten in approach 1, because with approach 1, those shards could actually be off from each other by like 5 minutes or something, because it's just going off of consumer rate for maintaining ordering, is like you would only get the same level of ordering as approach 2 as if the consumers were both at an exactly even rate, which is not what I think is going to happen. But you still get clock drift, so you're still going to be off you're still going to be off by like plus or minus somewhere between like 5 and 500 milliseconds. 500 milliseconds is a lot. If you like one of the prompts was, I think it was like 6 million hits within like 10 minutes. it was like 10K TPS or like 100K TPS. So 500 milliseconds would, if you only have 100 iPhones and you're off by 500 milliseconds, that is the difference between being first in line and not even getting an iPhone. So you can't do that. And for the iPhone problem, you literally need total order broadcast. So like the only solution to clock drift is total order broadcast. Which Spanner gives you for free. And that's why that's why the one guy I was asking about it earlier in the stream. It's a really good question for this. So what would be latency if we use Kafka? Is it an hour or so? It depends. I mean, it's going to be, it would be at least 100 milliseconds. So like I said, it was 10 TPS per so you get 10 TPS for reads, meaning 100 milliseconds minimum. So it's going to give you more latency. I guess the 100 milliseconds was really aptly chosen in that one specification for the problem, is that it completely eliminates Kafka for whether or not you get a free burger. And okay, yeah, that guy in the chat I think has a really good answer for what clock drift is. That's probably pretty good. Here, I'm going to zoom out a little bit. We're going to keep going through the questions. Clock drift just means the system time runs at different rate on different machines. Yes, that's exactly right. Yeah, he's got it. There's not such thing as synchronized clocks. Yeah, and so there's even that one thing that's called, I think it's like the FLP impossibility, is an argument that like clocks aren't real. That's not actually right. It's exactly is that you can't achieve consensus without clocks, and it kind of relies on how clocks, like you can't properly synchronize the clocks. Consensus can't be achieved if you don't have clocks. I believe that's right. There's a section about that in DDIA. DDIA has some stuff on this. So if you actually want the full proper explanation of FLP impossibility, check out DDIA. But it's this whole thing is another piece of like, hey, clock drift, can't really rely on wall clocks, which is kind of what the NTP is going to give you as a wall clock. Okay, next question. Can you please explain how timestamp across different shards of Kafka maintain ordering? So Kafka actually used to rely on Zookeeper, which implements ZAB under the hood. So ZAB is a total order broadcast protocol. And so you might think like, oh, I got a total order broadcast with Kafka, so that means that this is going to maintain total ordering for us. And I think it's just within a shard. I'm fairly certain that ZAB is just per shard. And so that would be why you're not maintaining ordering across shards. And then even if it was, you still have the consumers that are pulling off of each shard, and the consumers can still pull at different rates. Okay, I'm fairly certain ZAB is per shard ordering, total ordering. And then consumers can pull at different rates. Which is why you can't use that. That's why even if ZAB was for the whole thing, consumers and pull at different rates. So that's why it still is not a solution. But yeah, per shard ordering is maintained because it does actually run a consensus protocol called ZAB, or at least used to. I think they rolled their own within Kafka now. And so it's no longer using ZAB, and it doesn't rely on Zookeeper, but it does still have a total order broadcast protocol being used. And so that's why you can still keep it within ordering within a single shard. And then let's move on to other comments. Kafka latency depends on throughput of the Kafka node, which is generally calculated as megabytes per second, and the number of partitions / consumers. Yeah, well, so it's 10 TPS, and so that's where I was getting that 100. The 100, it's 100 milliseconds minimum, just because it's 10 TPS. And I did say minimum. So it's yeah, it's going to be 100 milliseconds minimum due to the 10 TPS upper bound. But yes, he's right. That's completely right, that you would still need to generally calculate it off megabytes per second, and you would still rely on the consumers being able to completely keep that Kafka stream 100% empty. But yeah, that's a good call out. And this is, I think, still going off of that comment right there. And this is me answering the comment. And oops, I'm using markdown notation. Since each partition is only allowed to be read by a single consumer, the best case is in partition and in consumer. Instead of Kafka, why not SQS? Back pressure. Back pressure. So SQS, I think, is kind of like RabbitMQ. RabbitMQ and SQS are they are message queues instead of streams. And what that allows them to do is that they can actually do they actually do support having completely in order. They don't have there's the two things that you could do with SQS. It was like at least once or at most once, or maybe that was something different. But SQS is able to maintain absolute ordering of all the messages because it's set up in a way where you actually only have like one machine, I believe, or it's in memory. So with both of these, I believe they hold things in memory. And so instead of streams where it's on the hard disk, and it also is horizontally distributed. So I think RabbitMQ cannot scale out horizontally. While with Kafka, it definitely does scale out horizontally, but it also has it also stores on disk rather than in RAM. So I don't believe that I don't believe message queues can typically scale out horizontally very well. And streams store to disk rather than RAM. In fact, Kafka does this thing called DMA, direct memory access. And that means that it actually hops over the CPU and just sticks it straight into the RAM. Just sweet. It's very fancy. Yeah, SQS does offer total ordering. Yeah, so that's yeah. It can only do that because it's not able to scale out horizontally quite like Kafka. So it's like I said, Kafka is able to maintain ordering per shard. And so like within Kafka, a single shard is able to maintain ordering just like SQS, but you're going to hit there will come a scale limitation. And when we're at 6 million within 10 minutes, you're just going to cap it out. And so you can't do that. And so SQS would not be able to scale, whereas Kafka would, by using multiple shards. And so it's not able to scale out horizontally quite like Kafka. Yeah, great question though. I know I'm aware of that. I know SQS has total ordering. That would have been so convenient with this problem if not for the scale that you're handling it at. Yeah, so SQS is kind of like oops, I dropped a letter. So SQS is kind of like a single Kafka shard, but also it stays in memory, which also allows it to speed up the processing time. But I think even with that, it's not going to be the interviewer is going to give you such a high scale that it'll force you to not be able to do that. That SQS just stops becoming an option. It's just, that's just like what they would not be reaching for this problem unless they wanted to force you to not be able to scale SQS all the way up to what you would want it to be able to handle for the problem. Okay, I think I handled, there's just one item left and then I'll move back to the problem. Just one more question, then I'll move back to the problem. And then, what's the definition of fairness? It varies. It varies depending on what's good enough for fairness. Yes, that looks like a good one. I'll add that to, that's from the Zoom meeting. There's like hardly anyone that comments in the Zoom chat, but again, I'm going to put the text file in a pinned comment below the video after the stream is over. And I'm pretty sure that he's talking about the same stuff that I wanted to talk about with the links that he retrieved. Thanks a ton for pulling that up. I appreciate it a ton. And again, this is going to be in the chat afterwards, the pinned comment afterwards. Yeah, okay. Kinesis, good question. I lied. I'm sorry. This is the last question for real this time. Kinesis is roughly Kafka. It's so Kinesis is also fair. Yeah, so also fair game. Kinesis is roughly the same thing as Kafka. It has a retention policy, which is it's where you store it for a certain amount of time for allowing the messages to replay, and that would only make sense if you're doing streams rather than in-memory message queues, because with in-memory message queues, after you process a message, you also delete it. And so it would just not make sense to have a retention policy unless you're doing the same thing as Kafka. So yeah, it's fair game. Good question. Yeah. Cool. All right, we can finally move on. I'm happy I answered all those questions. That's the whole point of doing a live stream, is that I can actually get back to you guys. So now we're going to talk about another approach. Is so in the end, like, you're going to have some kind of data store. We're not going to be able to use Kafka. So we're going to move on to approach 3. Like, so we've got these. We know that. We know that we can't actually have the stream there because that's going to be an issue. So we're going to have a data store. And so with the data store, we know that there's going to be a counter. And so when it comes to a counter in a high scale like that, you're like, okay, hot partitions, possibly. We're going to need to scale it out. So you might think, oh, I've heard of this really cool thing called a CRDT. A CRDT, a conflict-free, I know somebody's going to ask about this. Conflict-free replicated data type. I think that's what it stands for. Just go ahead and like Google CRDT, and Redis implements this. Redis does implement CRDT, so you can use distributed Redis to get a CRDT. And so the pro, so what you get, the pro is that it handles write conflicts for you. Conflict resolution, write conflict resolution for you. Which is great, but it doesn't handle the case of the dropped ACK. It doesn't handle the case. So you have a message that is coming in to your Redis instance. You're going to have, so you would have, we're going to have 3 different Redis instances, and they all have it's the counter data store. we're going to have 3 instances of Redis. So we got 1, we got 2, and we got 3. And they are somehow going to synchronize with each other on their count. We got some kind of counter. And that's great because whenever one of them increments, it'll tell the other one to also increment. And so this is all fine and dandy. And now I'm going to show you just why this is still naive. It's nuanced. Martin Kleppman actually has a video on this somewhere that I think has been posted a couple of times on my Discord channel. So you've got this request that goes in, and we're going to say that the schema looks a little bit like, we're going to say sale event ID like 5 or whatever, and then you got your counter, and we might have 6 million burgers. So we're going to say 5,999,999. Actually, you can count up from 0. So you can say that the count is currently at 456,789. And then we're going to have another one. It has the same event, and it's going to have its counter is going to be at, we'll say 567,234. And they're syncing up with each other on the way up. And then the issue is that when you have this request that comes in and you increment it properly, and then on the way back, it gets killed right there. So the ACK gets dropped. You got a dropped ACK. It just failed. And so then you're going to have to do a retry. And so we're going to draw that. We're going to draw our retry. So we're going to do that. And so then we're going to do a retry. But look, now we have incremented the counter twice for the same request. So you can get a double count. So this works fine if you don't care a lot about exact accuracy. So if it's like roughly 6 million burgers, you're in the clear. Roughly 6 million burgers is perfectly good. But look at the Amazon prompt. Look at the Amazon prompt. Do not oversell or undersell this item, not even by 1. So that's an issue. So let's record our learnings here. This does properly handle scaling up the counter because write conflicts are automatically resolved. Write conflict resolution is automatically handled, but double counts still occur. So it's fine. So this is fine, perfectly fine. If we're only shooting for roughly 6 million burgers, but fails the Amazon prompt of do not oversell or undersell the item. Let's hit new line on this. I'm sorry about that. Yeah, so it scales counter just fine for the 6 million burgers. And the burger app is also, it doesn't have payments because it's free. So this successfully, I think this would successfully handle the burger app. You also need to capture the user ID somewhere. So you would also need to have, and you could just use like Cassandra or something like that. And so you just have order success. It's this one's the counter data store. So you would successfully do the counter increment, and then you would store the order, which is just going to be the user ID. And you can just use like Cassandra here. User ID of DEF ABC, 1, 2, 3, DEF ABC. And so we've successfully recorded like, hey, this person, they get to come into the store, they've got their burger. So, I mean, you might also need to have something for user showing up to get their burger. And you might have like the clerk or something. Somebody's going to need to retrieve that data from the order capture store. But this is a little bit easier than the other one because you can just use Cassandra to handle that. Cassandra is leaderless and uses an LSM tree, so it can handle write heavy stuff just fine. The solved if an exact count is yeah, and then I mean, maybe like on the very tail end of that 6 million, it might make a difference, but it looks it like you've pretty much got the burger prompt solved. I think this would usually be a good answer for the burger prompt. Not the Amazon prompt though. This would not solve that. You want to do something a little bit different. We're going to solve that too. We're going to solve that too, but I definitely wanted to handle people would definitely reach for a CRDT as a solution to this problem. Plenty of people would totally reach for a CRDT for trying to solve this. And like sometimes it'll work. Like I said, sometimes a CRDT is a perfectly valid solution. But in other cases, it might not be. You need to be ready for that. You need to ask the right clarifying questions to your interviewer to make sure you can actually use a CRDT. And it's like you need exact, and then also it's yeah, I think just really the exact count thing. It's counting accuracy. Yeah, let me go through questions in the chat, and then we can move on to approach number 4, which handles all of the requirements exactly. I do have a solution that fulfills the Amazon prompt, and then I think this one is also good. Yeah, this one's okay. Let me do a quick thing of approaches. So I think we're going to also do, we're going to have to handle spanner, and we're also going to do manually sharded postgres. And it's special. I'm going to handle it like my special solution from the hotel booking problem that we found afterwards. And that one is also going to have some issues too. It depends on whether or not it depends on your definition of fairness. So with fairness, you've got total lottery answer. How much do you care? So you would ask the interviewer, how important is fairness here? Do you really care about fairness? Like to what extent? There's total lottery. There's clock drift is acceptable. And then you have total order broadcast, which is the most strict definition of fairness. I'll also show you guys why I think total order broadcast is a little bit ridiculous. Well, I can even do that in line right here. Like, so you've got these people that are they're placing orders. I'm going to cover this a second time when we do go over the total order broadcast solution. But I just want to give a quick overview of why I think this definition is a little bit absurd. And then I'll look at the chat, and we'll keep going to our other solutions. So you got this person over here, and you've got like 100 iPhones, and they're all competing to be in the first 100 orders. So they all place it right at midnight. So the issue here with total order broadcast is that even though you maintain an exact ordering right here, when you're hitting the DB, you're going to have exact precise, you're going to have like exactly precise ordering right here on the DB. The issue is that your users, you're going to have a guy in North Dakota on a dial-up connection. You're also going to have a guy in Seattle or New York City with a gigabit connection that's blazing fast. And so one of the requests is going to take 2 or 3 seconds, while the other guy is going to have, like a 100 millisecond response time. North Dakota dial-up versus Seattle. And like, you could even have a savvy user that's just running a script off of a EC2 instance. So some of your users might just have a thing that's just running in literally the exact same data center as you. You can do that if you're running your ordering service in AWS and you have it in like, Seattle 2 data center or whatever, there might be one of your savvy, very, hacker oriented users might literally pop up an EC2 instance right in a data center. They might stick it right on a Seattle 2 right EC2 instance right in that same building as you. And they would just have it run right at midnight on the dot, or even a couple of milliseconds beforehand, because they also have to account for that latency. But you see the issue here, is that I just think the definition of fairness is absurd, and there's always going to be a little bit of lottery baked into it, and that's why I think that clock drift is acceptable. Total lottery, like from approach 1, not acceptable. You need to have like some, I think trying to reduce the lottery aspect at least a little bit is reasonable, but I think some clock drift is totally acceptable. We're going to cover total order broadcast anyways later though. Yeah, okay. Anyways, live discussion questions. Yeah, live discussion questions. Let's hop into that. Live discussion questions. And okay, I'm gonna start with my folks on Zoom first. There's only one posted in the Zoom chat, so I don't feel bad about prioritizing that at all. Plus, everyone in the Zoom chat's usually been following me for a lot longer. Anyways, oh, and then on it, I didn't fill out this information. You guys might look at the text file after it's con. It doesn't handle dropped packs, meaning you can still get a double count off these 30. There, all right. Sorry for being all over the place on this counter approach. What about using a UUID or something similar generated on the client side? Well, so if you generate something on the client side, it can be a hacker and manipulate their timestamp. So like, a whole minute beforehand, they could say, hey, I'm going to submit this at midnight, like at 11:59 p.m. on the dot, or 11:58. They could submit something with a midnight timestamp. And they start making orders that double submits are processed as one full. So I have the user ID for that reason, is for deduping it. And then when you're handling this though, you don't have you can't dedupe that. Okay, I want to also have a nuance of there's this thing called a forgetful bloom filter. There's this thing called a forgetful bloom filter, CRDT, where it does actually use UUIDs for deduping the CRDT, but it's very non-standard and you have to roll the CRDT on your own. And so you could use Cosmos DB allows you to do that, but you have to roll the CRDT on your own. And so that makes it I guess you know what, we're gonna pop that in as approach 3.5 is Cosmos DB. You roll your own forgetful bloom filter, which allows you to dedupe against the counter, which is really, really cool. I think bloom filters themselves do still have like this little thing of positive versus negative. What is it? I think you can still kind of get a double count or an undercount on it in some rare occasions, but it's worth covering this approach. We're going to call this approach 3.5 is Cosmos DB. Cosmos DB, roll your own forgetful bloom filter, and it's non-standard to have this style of CRDT. Usually your CRDT, if it's counter CRDT, is going to be rolled as a grow only counter or a positive negative counter. If you allow it to go negative, if you allow it to go up and down, that's irrelevant to this case. We would only have a grow only counter typically for this use case, which Redis rolls, which allows to deduplicate counter increments, which is really nice. And so this little issue right here would actually be solved. And I think you you would still need to have this little thing right here. And then you would, if it gets dropped, so after doing this part, if it gets dropped somewhere around here or on the response, it gets a fail, they can try and replay the entire order. And so then they would still have their user ID. So I haven't put that on I haven't encoded that on my diagrams, but in the request, you would ideally be passing in a user ID. User ID, DEF, ABC, -123, DEF, ABC. There we go. And let's copy and paste that to all of my diagrams for the sake of clarity. Is that's what I envisioned on all of these diagrams, is that you would have the user ID in the request. If you're doing payments, you would of course also need payment details in there, but we'll get around to that before I close out this live stream, of course. But so yeah, I covered that thing. And then I need to talk about this. That allows for hackers. Yeah, so it's not perfectly solving it. And then for incrementing the counter on the DB, server can send this entire UUID or hash UUID plus user ID plus timestamp received at server. And then if ACK is dropped, resending the same request won't. That's only if you use a forgetful bloom filter. For grow only counters don't dedupe like that. Yeah. So only under forgetful bloom counters would this work. Yeah. Okay. There was a little bit more. Don't worry, I'm going to get to everyone's question here. Bloom filters can have false positives. It's the only approach that we can actually. It's the only. It was worth mentioning. So false positive, but not. Thank you for specifying that. I appreciate that. Thanks for dropping that information on this. Thank you a ton. To address hacker spoofing their timestamp on the client, there's nothing you can do to work around clients doing malicious behavior. Anytime there's some kind of request response going on, you can't get around it. Would it be sufficient to only use timestamps from when the server service entry point receives the request and ignore the timestamp from the client? Well, so that's approach 2. That's what approach 2 is, that you get your timestamp recorded on the ordering service. So yeah, that's approach 2, and you would still get clock drift though. You still get clock drift. Yeah, I like it though. I think clock drift is good enough. And that's because my point about North Dakota versus Seattle or New York City gigabit connections. It's like you're always going to have some element of unfairness. So like just give it up. Like I really think you should just give it up, because you're going to always have some level of unfairness baked into the problem. You just can't get around how somebody's going to have a New York City connection and somebody's going to have a North Dakota dial-up connection. You just can't get around that at all. There's no solution to that. It's just like the inherent environment that you're operating within. Yeah. So that is good enough in my opinion. Okay. But again, so even after recording the timestamp on the server, what are you going to do? Are you going to stick it in Kafka, or are you going to do it straight against the database? Because if you're going to hit the database anyways, you might as well just have the database record the timestamp. Or if you wanted to solve, if clock drift was not good enough, the database itself would actually be the thing that can do total order broadcast. And so we're going to see that. Let me get to other questions. But again, that is my roadmap for the rest of this, is that we are going to handle those 2 approaches, is total order broadcast approach and the just accept the clock drift approach. So hint. Questions in the chat though. Okay, I am not sure, just a guess. Will item potency not help here? So forgetful Bloom filter can achieve that. Regular grow only counters can't. Can't do item potency, like just flat out, they can't. And then I know a trick with Postgres that might kind of do the same thing. Yeah, so you just don't think Redis supports multi-instance transactions. I don't think so. If you're doing, well, so Redis has this thing called anchors. So Redis does support transactions, but if I don't think you can do multi-instance transactions. It's not really made for that kind of thing. That requires there to be a coordinator. I don't think Redis really does coordination from, yeah, I don't think it has somebody that like runs a distributed transactions. It's not really made for distributed transactions. CRDTs completely just avoid the issue of doing stuff like that. So I doubt it supports that. Single instance transactions are supported. And then how does approach 3 with multi-instance Redis handle failure? It does retries. I don't think I explicitly said that, but it'd do retries. Your ordering service would do the retries. Your ordering service. So we have the first one failing, and so you would see a 400 or a 500 status response. I should put that in like air quotes, but like response from Redis. I guess you can even co-locate the Redis instances directly onto the servers, but I don't know how that really works if you have multiple servers like that. That would be really weird, but I didn't really think about that a whole lot. I'm gonna write that as like an idea. I've never done that before on my diagrams. Co-located Redis instances with CRDTs. It's an idea. It's an idea. So we're gonna call that we're gonna call this 3.2. This one's gonna be 3.1. And then this one's going to be approach 3.3. So yeah, it's an idea. I don't want to dig into it though. And then so anyways, with approach 3, it would do retries, which is what results in the double counts. And then you get around it a little bit with the forgetful Bloom filter. But again, that's non-standard. You have to roll it yourself, which is generally viewed as incredibly risky. And so people don't really like that. They don't like to roll such a wild thing from scratch. Redis set also use CRDT. Can't we store the set of user ID here directly on Redis? That's okay. So that's kind of where I was going with Postgres. And then if you did a within instance transaction, you would maybe be able to get there. That's roughly where I was going to go. I was not aware that you could use sets quite like that. I like that. Yeah, good thinking. That I'm not that familiar with Redis. So with the burger one, you would be storing 6 million user IDs within Redis. I think you can handle that. I was just not familiar with how Redis set would work. Okay. All right. What last thing before we move on to more approaches? Last thing before we head on to more approaches. This. Somebody was pasting some information in the Zoom chat. For DB failure as opposed to server failure, Redis does have persistence, but this will probably prompt a follow-up question on how restoring from the persisted Redis DB. I don't know what AOF stands for. Let me go ahead and pull this link up really quick. Yeah, I was aware of persistence for Redis. Yeah, it's convenient. It allows you to use hard disk instead of the RAM for Redis, which is really nice. And yeah, it helps. And then so when you have when you're doing CRDT like that, it adds some redundancy across the multiple instances. And so I don't really care as much about the outage risk with Redis because you still do have it persist across multiple. You'd probably also want to do persistence like that. And so that's why I didn't even bring up the issue of machine outages in this case, is that you can just do, like you're doing your redundancy anyways, and then you can also persist it to disk, just like you had said. So that's why I didn't really even bring up the issue of DB outages. But again, if you get a dropped ACK, you're still going to have to do a retry, and that would result in a double count. So that's why I don't care about drop machines resulting in data loss. But again, you still get the double count. That's my summary take on that. I should maybe write that down. Sorry. So 2 items. I didn't bring up the issue of data loss, that the risk. I didn't bring up the risk of data loss. Persistence is an option, but you can still get double counts. Yeah, thanks for posting that though. I appreciate it. Okay, cool. I think we've handled all of the chat messages. Let's go ahead and keep on rocking. So we've got those 2. Let's move on to which one do I want to handle first? Sharded postgres. I want to do the sharded postgres first. Yeah, I want to handle sharded postgres first. I'm going to copy all of that. And now we've got approach 4, manually sharded. So this is my optimal solution. Okay, and I'm going to do that. Got the request come in, and you can also have, like I said, you can have the payment info. Ooh, that screwed up one of the arrows attached to the text instead of the diagram. And then you can also have your payment info blob right here. I'm just gonna leave it like that, but you would have credit card number, etc. However the heck that's going to be handled. And then you would not have a separate order data store. You're going to kill that. And then we would have these. Whoops. Kill all of these. And you don't sync across the instances, and it's no longer the counter data store. It is the order data store. Let's do that. We're going to do that, and we're going to paste it. So we're going to have, so it's inventory. We're going to say that we have inventory, and you would actually be counting down. So let's say that we have 6,000 items, and then it's a sharded counter. It's going to have, say 2,000 on each of them. So we're going to say that we have 1957 left on this one, and this one has 23 items. Jeez, my typing skills. And it's going to be an item ID instead of a sale event ID, because we're talking about the Amazon case, we have the item ID, manually started Postgres. So we would have we would have two tables here. We're gonna have two tables. Still, we have two tables. One of them is the inventory table, how much of an item is remaining, and then you have your order table. And so manually sharded, you got that, and then so you're just going to communicate with one of the one shard of Postgres. Have this just to kind of show that it is still it would interact with those shards. We need to pick out a partitioning key for all this crap, of course. But there's also going to be this second table here. And this would be the order table. The order table, which to have the user ID, EF, ABC, 23, EF, ABC. You can have their payment info for a given order recorded. So you can have your payment info. And now we actually have to handle payments because we only have a 50% discount instead of a free burger. So we're also going to have an order status. And so while you do your first receipts into there, you record your order and you decrement the inventory because it's on hold by the customer. So we're going to say placed originally for one given table. Let's go ahead and record the table names also here so that you guys can follow easily. So we have the inventory table, and then we have the order table. Boom, just like that. So you have it placed, and then we actually need to go to the payment processor and have a third-party payment processor like Stripe. And it's going to follow the what is it? Capture auth workflow, auth capture workflow. It's going to follow the auth capture workflow, which I covered before in a couple of other videos. Classic auth capture workflow. So you have you've placed it, and now you need to go ahead and try and process to get back an auth ID in your first thing, which will capture the funds on their card. And so now you're also going to record auth ID. Let's say AAA BBB -123 AAA BBB, and that is from the payment processor. And then after you've captured that in a new request over to the data store again, you're of course going to need to do your capture workflow to actually capture the funds. I guess that can actually be done asynchronous. That can actually be done as a DB trigger. So you actually don't have to do that live. I actually literally just realized that second request. So you've captured the funds, which means the payment's not going to fail. It's like reserved on the card. Whenever you get the auth to go through, it is reserved on that card. And then if the merchant fails to do the capture step, the second capture step within 2 weeks, the funds are released back to the card. So if that automatically handles the retries for reserving multiple items from a first one being unsuccessful and dropping midway through the process, is that the first attempt that gets dropped midway through the whole spiel here, the whole thing, it would just release the funds back to the card. So you can do that entirely async. And I guess then we would be able to do DB triggers. You can just have we could actually use a message broker. I said you couldn't do this. I said we wouldn't be able to use a message broker at all. but actually you can use it for getting that thing. Just literally, you could even do it the next day. That would be CDC with DB triggers for handling the capture. Second step. Very cool. Yeah, so way later, you would be able to have you could then have your orchestration component running, and it will pull a message. It'll pull, whatever the heck it is that it has to handle off of there. And then we will have our hit against this thing for the capture step. And it's okay to run that multiple times. It will not charge the account multiple times. And then finally, you will update the status on here from is it auth? So it's what is it? Authorized. And then you have captured, which is complete. So you could even just call that complete, which means you have now properly charged your merchant, your buyer's card for the 50% of the iPhone or whatever it is. And then I don't think I covered that. I brushed over this completely, but the reason why this handles deduping of the ID, unlike Redis, is that since it's on the same instance, if you fail on the ACK, if you drop the ACK, then that means that you've got that thing, the floating record. You're able to dedupe the things off of the second table. You do a transaction on the first thing. You do a transaction of doing the decrement and the placement of the order table. So the first thing that you do in your transaction is check if the user ID is already there. You dedupe off the user ID, and then if the user ID is not already there, you can decrement the counter, and that avoids double counts completely. So with this approach, double counting, you get exactly what the Amazon prompt has through having this co-located order table. There's no risk there. It's because it's not even a distributed transaction. That's one of the other naive approaches, I guess, would be a distributed transaction where you do a federated table. I could maybe go over that at the end if I'm feeling up for it, but it's roughly the hotel reservation problem that I did a while ago. So there's also the federated table, just like I did with hotel booking. I'm probably not going to get around to that. Sorry. Yeah. Then I'm going to really quickly draw out what you would do if you didn't do this DB trigger approach, and then I'll look at questions in the chat. So let's go ahead and capture all of this. So this is approach 4.1, and then I was originally going to draw. Here is 4.2. This is what I was originally going to draw, if not for this note right there. So we have you do your request, and then you do the auth step, and you're going to end up with like a whole lot of back and forth here. So you would do one, and then you would have another one for that auth step. And then you would go ahead and you would do the capture right there because you didn't think of doing it async. And then you would do your capture. And so you would literally have 3 back and forths against the database. You would have 1, and then you would have 2 for the auth step. And then you would store that you did the auth step. And then you would do the capture step, which is for deduplication. That's the whole reason why you do the auth capture workflows for it's to make your payments idempotent. Otherwise, you could end up with double charges, which customers would really not like. And so that's why this process is so convoluted, is that it avoids double charges. So this is 4.2 is just doing it like that as opposed to this, but they both are manually sharded Postgres. I need to talk about keys. So that's a sharded counter right here. That is a sharded counter. And you're going to get a little bit of a lottery on the tail end of that, but that is not specified in the prompt for the Amazon interview prompt. Is that on the tail end, as it's getting close to zero, you're going to end up with a lottery because one of the shards is going to run out before the others. But then this is the partitioning key. And then that is actually probably all you need for the primary key. It doesn't really make sense for, well, yeah, you have the DB trigger, so then you don't even need to worry about later retrieving the, you don't really need to do any key range queries. I guess you could do some small key range queries or something. But I guess you don't even really need to have any secondary nexus on that. And then, I mean, I guess the order, when you're doing your order, you're probably also going to need to know what item it is that is reserved. So you would also have item ID for the order. Which you can then release if the auth step fails. So you're going to do that. You're going to do the auth step. And then you would need to have a successful auth. And then depending on the result from the auth, you're going to, so you would still need to do at least one more call to the order data store. And depending on the results from that auth step, you would either update this to authorize, or you would have a payment failed status. And then you would release, you'd increment the counter back up. You'd release the inventory from that user because they failed to pay. They have a payment failed. Yeah, so that's how you do that one. Okay, let's go ahead and check the chat, and then we can go ahead and do approach 5 with Spanner, which is good for the iPhone prompt. That would be good for the iPhone prompt where it's literally 100 and you like, yeah. Okay, let's check. Geez, I think we had a lot of stuff going on here. What problem does the CRDT solution solve? This is from the Zoom chat. What problem does the CRDT solution solve if not giving you the exact count? Why is counter 4? Well, so it's because it scales up. The CRDT can handle the scale necessary for the counter. It properly scales up, but it does not. It has some degree of inaccuracy, which is sometimes okay. Some prompts do, but the Amazon prompt specifically does not allow for it requires exactness and doesn't allow for a little bit of leeway. Prompts might be okay with a little flexibility on the count. So like we talked about in the top K problem last week, is that with the Spotify top K problem, we didn't need an exact count. Count min sketch does not give you exact counts. And so in our prompt, if we wanted like roughly 6 million burgers, so EG is roughly at such a high number, it's like, I don't think they really care that much if you're off by 5. Like, for example, if it's 5,999,995, then I think they'd be okay with it. I don't think it'd be the end of the world. But if it's like 100 iPhones, I'm thinking they might want exactly 100 iPhones. And for the Amazon one in particular, it's a merchant, it's a third-party merchant running a sales event. They would not be okay with miscounting their orders at all. That would just not be acceptable with Amazon. 6 million burgers, though, it's yeah, I think they're gonna be okay with being off by 5. That's not the end of the world for them. Okay, did I answer the whole thing? Why is counter for sale event equals 5 different counts across nodes? I'm showing that so it would be the same count across all of them. It would. You are right. You are right. It would synchronize it. It would. It would. That's not correct here. Good catch. Thank you. I appreciate that. And so that's the idea of the CRDT, is that it would actually synchronize those counts exactly. Yeah, that's a more accurate depiction. I appreciate that. But for a sharded counter, it would actually be different. So this one's accurate, but good catch. I do appreciate that a ton. I think I'm misspelling that there. Yep. What about sales where users are allowed to buy multiple items? I would split them into multiple orders. Amazon actually does that under the hood, and in this case for flash sales, I would particularly care for I'd particularly want to do that. That's an easy hand wavy. Whoops. That's a hand wavy solution. I'm sure there's approaches to do that, but like in general, when you do a multi-item order on Amazon, it's for when it's not Prime Day, it's not Black Friday, and like you don't have to worry so much about that stuff. And but actually, I think whenever you're doing an order against multiple merchants, there's a tendency to split it up into multiple orders for each, where each merchant would actually get a different order ID. And so it actually does split it under the hood for multi-merchant orders, like where each item is from like a different seller. But like if it's 2 items from one seller, I think there was a greater tendency for it to not split. Anyways, that's like a thing you can do. Maybe I can revisit this way down the road and try and not say that. This solves the burger issue though, where you don't have multiple different types of orders. Yeah, that's a fun nuance though. That's a way to personalize it, make it a much harder problem. Yeah, you are throwing a wrench. Yeah. So that's why I feel so much okay with doing such a hand wavy approach. It's a cop out. I'm copping out. That's my cop out answers. I'd split it into multiple orders. And say there's an option for quantity when buying, but customer submits original request for 2 orders and decides they want 3. So for quantity when buying, so what you can do here is you can also have item quantities. You can also have a item quantity for the item ID. So then we would do, actually, so with the orders, you would actually end up needing to have both of these for the split order, because the user might have multiple orders at the same time, and you would actually need to have the order on the appropriate counters partition. And so you'd actually partition by the partitioning key and the item ID. But you can also do the item quantity, and then you would decrement by that amount on the counter. So if you wanted 2, you'd be fine, and then you could release that if you get a payment failed. You would just yeah. So the quantity can be handled fine like that. You just need to add it as another attribute on the order table. Okay. Changing their mind though, we're not going to handle that. That would have to be so we could say there's canceled orders, otherwise they would need to for ordering more, they'd have to submit a second order. Otherwise, they could cancel it and place an order with a higher quantity. So this is starting to get into a little bit more of the e-commerce problems territory. Under the hood on Amazon.com, when you place an order, it actually doesn't execute it for 30 minutes. It just holds that you've placed it for 30 minutes. That's how they implement cancellation, is that you have up to 30 minutes to change your mind. So it actually doesn't even attempt to charge it for 30 minutes. It's just sitting there for 30 minutes before it runs the off part of the workflow. Cancellation only works via delaying payment by 30 minutes. Yeah, so we're not going to have that. We're not going to allow for that in this case. If it's 100 iPhones that are selling out in seconds, like you can't just allow it to be like held for 30 minutes. Well, I mean, okay, so I do kind of start to see how you could implement that, is that you could have a holding period, is that now you can have placed, and then you have like a hold period. And then after 30 minutes, so if they change their mind and they have canceled, it'd be like the payment failed and it would release it back into the inventory again. So then cancellation, we can actually implement fairly easily here. And then you would just have the inventory frozen up. So you can have it deplete for a period of time. And then after 30 minutes, or whenever they hit the cancel button, you would then allow it to release the funds back. But yeah, I mean, that would then mean that you could also have a 30-minute period until you would hit the payment faileds coming out. So that would mean that like it would decrement to 0, and then 30 minutes later, the inventory might start going back up again. So it'd look like it sells out in seconds, then 30 minutes later, it's gonna look not sold out anymore, which would be really fascinating. Yeah, you can do this though. Yeah. Very fascinating. I didn't realize you could actually do that with this problem. Okay, that's all the Zoom chat questions. Let me check out the YouTube chat. Redis set also uses CRDT duplicates. Will yeah, okay, I answered that one. Okay, and then we have this one. So you have to run Zookeeper then. So I'm going to cover in my fifth approach, I'm going to cover Spanner. Which also runs a thing. I think Zookeeper does set up, it does have an approach for global counters. I don't know how well it scales. And then I think for Spanner, it even does a small trickery where it does Paxos groups. So I don't know if it really even does. I don't know how that works for global counters. That it still might be copying out in some way. It might not actually have true total ordering with Paxos groups on Spanner. Yeah, trying to get a global counter off of Zookeeper though. I can't. So you know what? Let me try and sketch that out. Let me try and sketch that out. So we're gonna have the approach of the zookeeper sketch. I just want to kind of try this out. I used to have zookeeper in so many of my so I used to think it was like a fun design component to use, and I think other people like try and do that too. I've seen it in like other videos as people try and use zookeeper for stuff, even though it's like within Amazon, there's like nothing that uses zookeeper. I talked to principal engineer and I asked like, hey, have you ever seen zookeeper as one of the as a component used like in the real world at Amazon? And he said no. He said no, zookeeper is not used anywhere within Amazon. So like somewhere in the call and response process, you would be hitting zookeeper to request a counter ID, to retrieve a counter ID, and then you could store it in the order data store or something. Somehow, yeah, I'm just trying to think here. It's so you have total order counter. It's an interesting idea. It's an interesting idea. I would much rather just leave that left under the hood and not actually try and do it yourself. So for example, just leverage Spanner, which will use an order counter under the hood. Yeah, I don't know how to, you're trying to expose it though, the actual order counter, and leverage that in design is an interesting idea. I haven't thought enough about that to try and like have a more fully fleshed out solution, but I did want to record that. Yeah. Okay, we got this. This is my first choice as well, though operationally this is the most expensive. 100K TPS would require 20 physical shards. You were probably talking about the PostgreSQL one. Yeah, I like this. I like these two approaches. They are cool. They're yeah, this I think the clock drift is just totally acceptable. And then I mean it would result in like for the Amazon approach, it's fine. I mean, if you're doing the iPhone one, you might care more about total ordering, but whatever. Um, here we go. Yeah, I just like the Postgres solution. There's no, you're not copying out by leveraging Spanner or anything like that. It's a fun answer. It's like what I would expect for this. It's the kind of, it's the answer that I typically expect that doesn't have any cop outs. Uh, so yeah, that's a pretty valid concern. That is the valid concern. I'm not sure if it can handle 100K TPS. Well, so it does a periodic total order broadcast, so you don't have to do the total order broadcast with every individual request. I believe it just kind of batches them up, and then they come to a consensus of ordering under the hood, or like somehow does the total order broadcast while holding a request on the machine. And so then they do this little chat while you've got like 10 requests or something batched up on each node. So I'm gonna say good question. How high can you go with Zookeeper? How will how will be handling the case where we have inventory on some other shard, but user will belong to another shard? Right. So that is the unfairness of the Amazon question, is that you on the tail end, as you're getting close to yeah, so yes, the Amazon prompt, the e-commerce flash sale prompt of God, let me check which exact one I was thinking of. I want to know exactly which prompt I was thinking of. This one, yeah. So the Amazon prompt. Flash sale would result in unfairness. The tail end of inventory count as some shards run out before others. So it does have some degree of unfairness. You know what? I thought I was handling unfairness properly there. It's not actually handling unfairness properly. It's, yeah. You know what? I need to note that. This actually would not handle fairness as some shards run out before others. And then, I mean, you can go ahead and like have something that tries and shuffles the counters across each of them, or you can do like retries, try and like put user ID, you can choose some other partitioning key and then somehow get the order onto a proper partition, and then you would store the partition with whatever you hand back to the customer. And so then you would have like so you can do something like store hold in the backend service a partition ID rather than using the user ID that was provided. So you're doing these like you're doing retries to try to find inventory, which would then also mean that would be like that would end up as a key range query, a scatter gather that actually results in scatter gather. So yeah, that does kind of break it. And so I think we can just go ahead and settle with a statement of this actually would not handle fairness quite so well as some shards run out before others. Yeah, that's a good note. The approach of using spanner will definitely have fairness handled properly, though. We will definitely be handling fairness properly with the spanner approach, I believe. Okay, so we got that. Let's keep going through the questions. Don't shard user ID, just round robin. Well, let me record this. It's you would need to then have that also requires total ordering, is that you can't have since you're horizontally scaling the backend service, that would mean that you would need to round robin off of each individual machine, or also like across all the like last 10 or so items would definitely be handed unfairly. It's like you just can't really do that properly. It like there's going to be some spots on the tail end that are going to be unfair with round robin, no matter how you set it up, even if there's no coordination, or like if you do coordinate across the machines, then that introduces overhead and that becomes just a wildly overcomplicated answer. So you wouldn't be doing that, and then you can just have each individual machine round robin by at the request level of that individual machine, but then you would still end up with the last 10 to 20 items being handled unfairly. It's an interesting idea, though. That's an interesting idea. Yeah. Okay, let's keep going. It's part of second approach, timestamp. It's getting captured, but I could not understand how timestamp will help in ordering, as message will be distributed across partitions. Well, so it it'll not maintain the ordering on Kafka, but you would be able to store it and then figure it out later. And so like you would empty the Kafka shards out. You would rely on these task runners to fully pull out a whole bunch of messages until like you've emptied the stream or something. And so then you would asynchronously handle you would asynchronously order all of the messages into a data store at some point down the road. So yes, processing, the task runners would not be pulling out the messages in the appropriate order, but you would go ahead and like have them stuck into a data store, and then you would like do some kind of, it would basically turn into an OLAP query. It's a little bit of an absurd approach, but it shows that you wouldn't have to worry about keeping everything scaled up like at the time of the sale. Like during the sale, when you're just getting slammed with so many orders, you would not have to keep all this scaled up, but you would end up having to do some kind of absurd OLAP query later on or something like that. So yes, it's not the best approach. I wanted to cover it though, because people think like, oh, Kafka does total order broadcast. I'm sure that might work. It's like, no, not really. So I didn't want to detail that. Shouldn't sharding key be item ID? Well, no, because the individual item is, if you have an individual item on one shard, that shard, you'd have a hot partitioning issue. So the issue is that the item ID is a hot partition, and so hot that you need to do a sharded counter, and you would store the counter across multiple machines. Yeah. Okay. Oh, we are almost done with the messages in the YouTube chat. I've almost cleared all those out. Okay, but I guess that still has the risk of landing on a shard, unluckily. So maybe we have to try multiple. Yeah, I went over that a little bit. I went over that a little bit, is that you would basically end up with a scatter gather. And scatter gather doesn't scale well. Okay, Cloud Firestore can be used for distributed counter. I haven't actually heard of that account. I've actually never heard of Cloud Firestore before. That sounds familiar. I think I've heard that GCP does sharded counters for you or something, which is really convenient. But again, it's like if you're leveraging something like that, you might be copping out. That might be a cop out solution, kind of like just throwing spanner at it. But that's yeah, I haven't really investigated that before. And okay, quickly skimmed through some Zookeeper doc. It seems like with a single leader quorum setup, it can handle 50K TPS. Okay. Well, so your interviewer is definitely going to do some kind of absurd number where it breaks that. And that's a surprising number, though. I'm surprised it can handle 50K TPS. That's really solid. Okay, won't inventory tables inventory count be a single point of failure? Well, so that's how it is with yeah, you so it's acceptable to do that with you're correct that it's a single point of failure, but so is like the payment processor. And so is the ordering. Well, I mean, so ordering service, there's multiple machines there. And so it's like horizontally scaled out with redundancy. So with a sharded counter, it's not a single point of failure then. Well, no, just the counter, just the counter itself isn't, but if it's down for a specific shard where the user ID would go, then it would be. So usually you have some kind of failover. So you'd be using some kind of single leader approach, such as PostgreSQL, and so you would you can set failover with one synchronous follower, which I'd imagine that's what DB does, which is what I imagine DynamoDB would do. Does, which is what I imagine Dynamo does. Yeah. Yeah, you're kind of correct. It's kind of forgivable, I think here. It's kind of forgivable to do that. I guess that's a fair call out though. Let me look at what's in the Zoom chat. There's a couple of items here. It's small. No, okay, I didn't see that one yet. Yeah, okay, I got that one. I did not answer that one though. Oh, where did it go? Sorry. Okay, here we go. Found it. Okay. Answered him. You don't have time to answer. Could you give a brief overview of the two PostgreSQLs? No, nope. You got to rewatch the video. Nope. Sorry. Well, okay. One of them has a DB, so it's just whether or not the capture step is async. That's it. Maybe that is a little bit useful to explain. It's just whether the second step of auth capture is made async. There we go. Yeah, you can completely offload that work to being completely like way after the sale by making that second step asynchronous. That's very powerful. Answer estimates max of around 1,000 TPS per node on Zookeeper also includes lots of considerations. Okay, I can actually pull up that. Oh, maximum TPS of Apigee Edge. Stop it. Okay, Edge private cloud. What is this? This is dank. This looks dank. This is going in the resources. Yeah. Fascinating. Yeah, we're gonna put that into the resources. Maybe we're just gonna call it like live resources. I'm gonna say live resources. Yeah. It's really, I suck at doing machine count estimates, and I don't think I'm actually going to go into them in this case. There's even a video recently that argued against doing machine count estimates and interviews completely. Although if you interview with Google, you can't just tell the interviewer to F off. But in a lot of places, you definitely don't need machine count estimates, and they're just so tricky. But like, so sometimes like you can find resources that like do them right, and they're not hand waving. They actually are like not quite estimates so much as like exact, proper, just wildly deep estimates. And this looks like it might be one of those. Yeah, you know what? I'm going to record that too, and I will not pull it up because that might it's I won't give in. We're gonna keep moving on. And again, I'm gonna drop the file in a pin comment afterwards. Oh, the 50 kTps is totally different than 1 kTps here. Varying estimates, interesting. All right, cool. We've gone over all the chat questions. That's the whole point of being live, is that I can actually answer your questions. Now we've gone through them all. Very nice. Okay. We want to cover spanner. Yeah, I want to cover the spanner approach. That is all I have. That's our last diagram for tonight. It's the last thing we're going to cover is spanner. So I did not want to cover the federated databases approach. We already covered that kind of in the hotel booking problem. It has its own trade-offs. And I'll in this live session, you can just refer to the hotel. Yeah, so we're going to cover this the spanner one though. I should maybe reorder these. 4, 5 spanner. Cool. Let's check out spanner. It's going to look like this. It's going to have spanner approach. It'll look like this. And we're going to say approach 5, spanner, which does total order broadcast for us. Got the requests come in. You can have payment info. We got the ordering service. We got our order data store. It'll handle sharding for us. It'll handle, okay, I want to copy over my schemas. Like that. And you've got the table, and you can do a auto increment here. Do an auto increment here. So do an auto increment ID for an auto increment it. I imagine there's a way that I'd be shocked if Spanner wouldn't let you, or maybe like through some kind of like really challenging SQL query syntax, you can like set it up to figure out the auto increment index under a specific item ID. Well, that would be a really expensive key range query though. That'd be a really expensive key range query. I would bet that with the total order broadcast, you could probably figure out the it would allow you to set up an auto increment under possibly within the context of an item ID. So you would want to have like for a given item ID, you would have a auto increment. So it's an auto increment on an item ID basis. On item ID basis. And we're doing the 100 iPhones. We're at iPhone number 85. We record the user ID, item quantity. You do not have multiple free iPhones per user for that. It's you have a user ID. You don't need payment info for the iPhone 1. Where is it? Oh, it's $100 per iPhone at midnight. They didn't specify payment can fail, but I mean, I guess we could kind of keep that in scope and see how much it screws with us. Yeah. So you have a bunch that are successfully in the placed status. You would not have hold because you're not allowing them to cancel their orders. You don't have to worry about that in this case. You would have it placed. And then you'd probably go through the authorized step. You would need to record that. So you'd have it authorized. And I guess you could, so it'd be either authorized or payment failed. You could maybe leave the actual payment asynchronous like in the last problem. So then you don't have to worry about 5 or 4. But then for everyone that's waiting and hoping for somebody ahead of them in line to have a payment failed, could have them in a pending status. You could have them in pending. And then if you get, if you have something that hits the payment failed, you can go ahead and use a DB trigger. So off of a payment failed event, you could have a DB trigger, and then it could go ahead and look up somebody that I am so sure that Spanner has DB triggers. If it doesn't, that would just be shocking. It's gonna have a payment failed. And then if it's in the, you could even have people that are in pending go ahead and have their thing authorized. So just to have everyone, you have like, you just let everyone go ahead and have an authorized payment of $100. And then you could go ahead and just have a certain set proceed, but it would be, so anyone that is beyond an auto increment of 100 would have a status of pending, while the first 100 could either have authorized, placed, and then if it's authorized and you currently have the thing allocated, but it's not in completed yet, then you would have okay, what is it? Placed, pending, authorized. What's that? You would want like seized, held, or I guess you could I guess we could bring back the state of hold. So we have hold, as in you're holding one. You've got a successfully obtained one, and your payment is properly authorized. Oh, and that's right. Payment failed was actually out of scope. And so then you can dodge having this task runner thing. And so you can actually go ahead and do, we're going to remove the payment failed out of scope. Do that. And then we would delete this. This would actually be, so you'd have the authorized step, and then you can go ahead and have it move over to the broker. Proceed with properly withdrawing the $100, properly transferring $100 from the held, or like the authorized $100, and completing the transaction to the merchant. And then have the payment processor over there. So we got this thing like that. Do this. Okay. And yeah. So then this looks more like the other approach from over here, where it's we got the task runner, and then it so it's later doing the 1, 2, 3, 4, 5, escape, and then we write do this for updating to completed. Yeah. Yeah, so that would be with Spanner. I think we did that right. Oh, and we don't want this thing. Okay, I'm just trying to think if this is, yeah. Oh, and it's the iPhone problem, so we wouldn't have 1957. We would have like, actually it's not even sharded. We would just yeah, I don't know how the heck you would do that with Spanners. They're all still trying to hit the same thing, I think. You wouldn't have, yeah, I guess you can go ahead and do that. You don't like do a sharded counter. Maybe you would mix it with something like Firestore. Yeah, you'd probably want to mix this with something like Firestore, but I'm not familiar with it. Firestore. Sharded counter. I think this is our spanner solution now. So you don't actually need to handle payment failed. Okay, let's check the chat. Let's see how everyone's feeling right now. I'm going through the Zoom one first because they're usually a lot shorter. Somebody has posted some SQL for us, which I appreciate. And then, yeah. Test it in staging first. Okay. Probably expensive, just an example of SQL approach versus Spanner. Yeah, like so Spanner actually supports PostgreSQL syntax for the SQL. So you actually are able to query it just like you would a PostgreSQL table, which is really cool. Okay, and I'm looking at the YouTube comments now. I only missed one there. Very cool. Why not just store each order as a row in Spanner, and run a transaction of count rows, then so count rows, that sounds like an OLAP operation, which is expensive. And then so the whole point is that you should be able to partition the data across multiple machines. And then if you're doing count rows against all the orders for a specific item ID, that would mean that you're doing a scatter gather against all of it. And then you've killed the whole point of partitioning since you're doing the scatter gather query. And plus then you're counting up all the rows. That's like count rows, then insert. Yeah, so you're doing a scatter gather query and then insert, which means that's then a write operation. And I should write out my thinking here. It's a good idea. Yeah. Yeah, scatter gather just doesn't really scale that well. 1 million is not too hard to count. It is if you're doing it at a TPS of 100,000. 1 million rows to count is actually a very large amount to count when the TPS is 100K. Yeah. Not so tablets is a spanner term. That is a spanner term. I might just be following poorly. Feel free to drop a comment to correct me if there's some kind of spanner trickery that I'm missing here. Feel free to comment if I'm missing some kind of spanner trickery, but I don't know. It seems like it'd probably result in scatter gather, which is a no-no. If I recall correctly. Cool. That handles our last approach of the night. I don't see any other comments. I think I've gotten back to everyone. Some of you guys are absolute troopers here. I can't believe you actually managed to watch this whole thing. This is my longest video ever, but this problem has intimidated me for months on end. I'm serious. I first saw this thing all the way back in November or December. And I mean, I was thinking the same thing here as the interviewing.io people. Was like, hey, maybe you can get away with the Kafka thing, but really you should be trying to handle it synchronously instead of asynchronously. And that is just so hard. And I actually didn't even think about this trick here with the async capture step until on the spot. That was crazy. I don't think I would have been able to figure that out months ago. So yeah, apologies for such a long video. Thanks a ton for watching. I hope you guys have actually learned some stuff. Feel free to drop a comment if I missed any approaches. I love seeing new approaches that people come up with. And again, I'm going to drop these diagrams in the comments below, as well as the text file. I appreciate it so much that you guys have been watching. Yeah, I'm gonna paste these just in case there's another question. I would love to try and make sure I handle any comments live. Yeah, it is. It was a good idea though. I appreciate it. I love seeing new ideas. And yep, I will. Yep, I definitely will. I absolutely will. All right, cool. Thanks again for joining. I appreciate it. Hope you guys learned something. Here, I'm going to end it on my favorite approach. This one. This is my favorite approach. There we go. We're going to end it on that. Cool. Yeah, I'll let you guys go. Thanks for joining. I will see you next week with another exciting problem. Thanks a ton. See you guys.